Try on top next to 100 plus the icon on the right side. Yes. Now it's full screen.
It works.
I will let you deal with the slides, Jeffrey. You seem to have found the way.
Okay.
Thank you.
I can now see the other screen in Miteco. I just see this slides. It's 8:30. Do we start now? Can you hear me?
We can hear you.
Okay.
We hear you well, Jeffrey.
Let's start.
Sure.
Hello, everyone. So this is COIN Research Group. We have three chairs, me, Jeffrey He, and Eve Scholar from San Francisco, and Malaysia C in Montreal. Unfortunately, all of us cannot attend this meeting in person. It's really, I know this is a really beautiful season in Japan. Very pity. This is not well for IETF meetings, so I think you should pay some attention to this, especially for the RPR part. If you have some patent or something related to RPR, you should disclose them. This is also some politics best BCPs. And this is some achievements for this meeting. You have already, I guess you have already accessed Miteco, and we have some links for live minutes and the meeting materials. So if you want to read the slides in real time, you can access that. And please remember, this is a research group. We are not a typical working group in IETF. We are not a standard developed organization. We focus more on the research. So this is today's agenda. So Malaysia, will you introduce this?
Okay, so today, compared to usually, actually, we're usually very, very big on having meetings with lots of very scientific presentations, but we decided today that we would have a review of documents that have been in the queue for quite a long time. Sadly, my co-author, Aikunsa, is sick, and my other co-author, Dirk Trossen, is in a plane because there were problems with strikes. But I see that we have some of the other authors of the use case analysis and the terminology that are there, so they will be able to support us. We also have a number of new drafts going into SDN, a framework for control environment, a very interesting problem that was raised, and actually just is not just a draft, but it's also more of a technical discussion, research discussion around security and COIN, And that was actually very much part of our original charter, so it's very important to have it. And then another problem in data-driven coordination. Sadly, because Ike is sick, maybe the research topic, we may have a larger discussion. And we kept quite a long time at the end to start maybe addressing larger topics and directions, and have time for once to answer questions. Next slide.
Yeah, so these are current research group drafts and individual drafts. As you may noticed in our mailing list, some people are requested to reference to this document. So, but some of them are expired. So we encourage the authors to update this document if you want to continue them. And then also we chairs are thinking that if we can move these research documents to a last call, based on the discussion in this meeting or after this meeting. And this is some milestones we need to update maybe later. Then the presentation and discussions. So which one is first?
I think it's
this one,
the
Louis,
one.
right?
Pardon me?
Louis?
It's Louis, yes.
Yes.
Yeah, Louis is the first,
Louis,
yes.
do you want to share from your side?
Is Louis there?
Yeah, I would prefer you can share.
Okay.
If possible, if not.
Find the document. Louis, which one? Not this one.
Yes.
Okay, thank you. So I'm Luis Contreras from Telefónica. I will present this draft on behalf of my co-authors, Medbu Kadair from Orange, Diego López from Telefónica, and Carlos Bernardos from UC3M. Sorry. So what we will present today is an evolution of a layer architecture for SDN that we moved in IETF in the past. So the idea would be to do some incremental work on top of this architectural framework. Next, please. So next, okay. So the background is this architecture, this original idea was adopted in the SDN research group, but at the time that this research group was dismantled, we moved the draft to the independent stream editor, right? So the draft becomes an RFC, the 8597, and essentially what proposed this architecture is a layer cooperative interworking between the control of the services and the control of the transport capabilities. Next slide, please. So here you can see the representation, the illustration of the architecture. So somehow we divide the control responsibilities in which regards to the service and with regards to the transport part. So we define this functional strata, service stratum, for everything related to the service itself, and transport stratum. And within each of the stratum, we define different planes, the control plane and the management plane, that are surface plane, and the resource plane that works on top of all the resources for each of the strata. This was the original idea. Even though the strata are separated, we propose to work in very tight coordination among both planes in order to achieve the end-to-end service delivery in a controlled manner. Okay. Next slide, please. So departing from the architecture that you saw before, the idea was to do some incremental work on top of that because of the new kind of services or new kind of challenges that we are facing in operational networks. Essentially, there are two new drivers for this. The first one is that the networks are evolving for interconnecting compute environments. So the idea would be to have this compute component as part of the architecture. So also creating, considering the resource plane, control plane, and management plane of all this environment. And the second point is that more and more the operations are leveraging on artificial intelligence, machine learning capabilities in order to perform these closed loop automation management loops, right? So the point was to do this expansion of the architecture considering these two different dimensions. Next slide, please. So then we, well, oh, okay. Here the colors probably are not very, well, I think that is sufficiently, you can distinguish sufficiently the point. So essentially what we created was, well, first we renamed the transport stratum, that was the previous name, by the connectivity stratum, just for reflecting better what would be the aim of what we call in the past transport stratum. So essentially working with the networking part, the connectivity part of the architectural framework. Then we added this compute stratum for reflecting the introduction and the management control capabilities for the compute side. And then for each of the planes, we added the learning plane. For each of the strata, sorry, we added the learning plane with the idea of these planes to work with the data analytics and the processing of the data of each of the particular strata. As you can see, all of the idea is to integrate all of them. So even though they are separated, somehow they need to interwork and collaborate in the final end-to-end delivery. So this is why you can see the different lines interconnecting the different planes, like the resource plane, the control management plane, and learning plane of all of the strata. So the idea is that all of them can interwork. For the learning planes, there will be probably different time scales for each of the components. So the idea would be to understand how these can interwork in a smooth manner, and the same idea for the resource planes and control management plane. Next slide, please. Well, this is a verbose description of the figure, so I think we can skip. So next, please. Yeah, regarding potential research directions that we identify, well, so essentially probably we can propose some use cases that probably could help to understand better the architectural capabilities. This is something that we could consider to include in the draft. Also to work in different aspects of the architecture, like the communication interfaces between the different strata and the planes themselves, the deployment of scenarios, so also in understanding how this architecture could fit with legacy scenarios as the ones that we have today. Potential, well, use cases is already mentioned. Also the link with ongoing activities in NMRG and COINRG. The reference here to NMRG is because we presented this architecture in the past in NMRG, and the NMRG chairs recommended us to present to you here in COINRG. So this is why we had here the reference to NMRG. Then explore novel architectural approaches. Probably, for instance, one way to follow would be to consider a bus architecture for interconnecting all the planes, service-based, bus-based architecture. Working in the APIs between the different strata, explore probably the intent-based API as well, and trying to identify data models for the exchange and aggregation of information between all the different strata and planes, basically. Next, please. Yeah, next steps, essentially to set the scope of the draft aligned with the scope of COINRG. Collect feedback from the research group to see if this is of interest for you to continue exploring here in this home, and prepare a new and more detailed version for next IETF, and essentially trying to collect your feedback. Thank you.
Are there any questions? I have one. This is Marie-José. We're supposed to tell who's speaking when they ask a question. This is another thing we have to remember. You say you want to set the scope of the draft to be aligned with the scope of COINRG. But if you go back to your slide that has the all the boxes, I think it was your third slide, fourth slide. It's very, yeah, this one. This is very traditional, I would say, SDN, right? So where do you see that the coin capabilities happen? Because you have a compute stratum, but it's not clear what that compute stratum does.
Yeah. So how what we had in mind at the time of defining this was the idea of the kind of situations that we face today in operational networks like the ones for Telefonica. So essentially, you will have some cloud manager capabilities handling the computer stuff. You can imagine OpenStack or Kubernetes or whatever, and we need to provide a kind of orchestration between that part and also the traditional SDN part in the transport network and coordinate with the service part. So imagine that we deploy some service function in a compute environment and we need to provide connectivity to that service functions, a service function chain, for instance. So the point here will be to integrate everything together to ensure that the end-to-end delivery is smooth and is adequate and appropriate to the expectations of those service functions. So then, in relationship in the relation with COINRG, we think that probably having this kind of orchestrated behavior between service, connectivity, and compute could fit in the scope of COINRG. This is basically the point.
Okay, because you have a resource plane at every stratum. You have control planes that are distributed. You have a learning plane. I would suggest that you should rearrange this to be maybe a bit more clearer in terms of what having the compute stratum would actually help the other things and maybe move boxes around. I'm not saying it's not interesting. I'm just saying that the way it's presented, it's not clear how that is going to evolve, and maybe it's me, but yeah, okay. I would just suggest that so that the scope is clearer, actually.
Okay. Thanks for the comment. Thank you.
Any other questions from anybody? I don't see anybody in the queue right now, but is there any?
Sorry, I didn't add myself to the queue first. Somebody do it for me. Dave Oran, Network Systems Research and Design. I have a question. There seems to be an implication in this slide that I hope isn't true, which is that there's a hierarchical relationship between the connectivity and compute stratum, where the connectivity stratum is somehow at a higher level than the compute stratum. I assume that's not intentional. It's an artifact of the way you've drawn it.
Yeah.
Okay.
That's the point. It's not intentional. So this should be at the same level somehow. I mean,
so it's very easy for somebody looking at this to say the service level controls the connectivity level, which controls the compute level, which I don't think is what you intended.
It's not the intention. It's
okay, thank you.
Thank you.
Thank you.
Any other question? Okay, well, thank you very much for this. It's great to have new work, and it's great to see that traditional operators are taking notice of the work that's been done here. So thank you very much for this. Dino, you have a question?
No.
Oh, okay. So maybe we want to move to the next presentation.
Kehan from China Mobile.
Hi everyone, I'm Kehan from China Mobile. Hi Chairs, can you hear me?
Yes.
Today I'm gonna to share our research on the coin. Today we bring a draft called a generic coin framework in controlled environment. Next slide, please. In the past 5 to 10 years, we have seen a lot of research on programmable network. Programmable network devices actually have really inspired a lot of research, work like load balancers and firewalls in the area of coin. But technically, we think that they are not strictly computing in the network, but actually hardware implementations of network functions. We think that for the computing in the network, they are very closely coupled with applications. We think that the coin is actually to offload application-specific functions to network elements so as to accelerate applications. So these application-specific functions are described by series of computing primitives or called operations or semantics. And so next slide, please. Some academic research and industrial practice in coin has been summarized in this table, and they are mostly case-by-case design, and they need to rely heavily on programmable network devices. As we know that the network devices are owned by the operators or service providers, and if application developers need to define some applications, and also they need to leverage the capability of the coin, the capability of coin, they need to know some programming model like P4 or even chip-specific languages like NPL or other languages. And also they need to handle some programming issues on the host side, and they need to know more about C++ or Java. So this may raise a very high bar for the application development. So we think that we need to define a very application development. We think of a way to make it easier for the application development. So to make the app developers to better leverage the network capabilities owned by the operators, because most of the application development may come from the third parties. So in this draft, we think that we want to increase the generality and of the coin development and promote the standardization of the coin. So in this draft, we summarize some general computing primitives from the existing research work, and also that we also hope to promote them to be standardized, and these primitives can be implemented inside normal network devices rather than the programming network devices. So, and also we propose a generic framework of coin in the controlled environment. Thank you. Next slide, please. Here is the overall, it's a very initial framework of coin. It contains about 3 layers. On the top, there is a scheduling layer, need to decompose these jobs into host task and coin task, because we think that to make the coin to be scaling, some of the tasks may be distributed across multi-servers or multi-racks, or even across geographically distributed multi-sites. So the scheduling layer needs to think of a way to how to decompose these job tasks. And there is also a control layer, and the control layer may contain 2 controllers, and the host on the host side or the coin side, and they need to think of a way to make the end side and network side how to collaboratively collaborate more effectively. And also on the bottom, there is an infrastructure layer. It contains different it contains host side like GPU server, CPU server, and also network devices like switches, routers, or smart NICs. Next slide, please. So as I mentioned, in the scheduling layer, the policies, scheduling policy vary for different workloads. For example, for distributed machine learning training and MapReduce, they are different because one of maybe batch processing jobs and other might be streaming processing jobs. So these different tasks should be considered differently. So we need to think of but we also need to increase make them all down in the scheduling layer. So, and also with the addition of in-house computing technology, it is necessary to consider not only the host resources but also the coin resources. So next slide, please. So the control layer, we think, is the core of the entire architecture. So because they need to coordinate the host and the coin resources. And on the host side, the controller need to make the host application cooperate with coin processing. And because we think that coin processing may be a complementary work for the entire computing work. So on the whole side, they need to include some, they need to finish some the overall compute calculation task, which might not be done in the network side. And also they need to consider how to control the entire reliability of the entire coin work. And also on network side, the coin controller needs to manage network equipment and like their information, their computing capacity, their static resources, and also like network topology management, and how to route different computing tasks across different network devices provided by multi-vendors. So a very easy way, easy way to a very illustrative way to show the coin controller may be extension of SDN controller, and they need to store some information about the network devices, and also they need to store some information about the primitives that I mentioned in the first slide. So next slide, please. So in the infrastructure layer, and we have summarized different coin primitives that we hope to be standardized in the future, not exactly in the research. So like we summarize, here are some 4 basic primitives and their corresponding data structures in the existing work, like value stream aggregation. These are usually used in distributed machine learning training, and also asynchronous value aggregation. They're mostly used in big data analytics applications where MapReduce is needed, and also key value pair. They are used for caching, and also consensus. They use for synchronization in distributed systems. So so coin transformation of applications should be considered, and on the whole side, so in this way, the flexibly process of the data can be realized. So yeah, thank you. Next slide, please. So since the framework is very initial, and we will update it update the details in next meeting. So there are also some research challenges and other considerations, like how to realize efficient collaboration of end and network. For example, like fallback mechanisms, where tasks cannot be fully accomplished within the network. They should be finished at the end device, because the computing capability of the network may not be that efficient. And also the reliability and the correctness or idempotency need to be solved to maintain the coin results is actually consistent with that when tasks are fully accomplished at end devices, and also some cost requirements. So these are what we think to promote and contribute to the community, coin community. So welcome for some discussions and more contribution. Thank you. Any questions?
Yes, this is Marie-José. There's some noise going behind me, but that's fine. I do have a few comments on your presentation. First, you mentioned that you want to standardize coin. I think we mentioned at the beginning, now this is with my my chair hat, we mentioned that it is not the role of this community to standardize coin. We are going to do research, and so if the goal of your efforts is to come with a standardization effort, well, we may not be the right people. And the other, I think you've been very critical of the work that has been done in this group, and I think my text to Jeff went on this. You've been very critical, but at the same time, the 3 articles that you suggest at the beginning are articles that are previous to the establishment of this working group, of this research group, sorry. So those are old now, and I agree that was old. There's been an awful lot of work that's been done in this research group on resource discovery, the use of intelligent devices. It's not true that they're all network devices. You know that P4 has been ported to Pi devices, so you can do these things very much at the edge. There's been some work on device discovery. So I think I welcome the fact that you're doing a layered architecture that I think is valid. As you know, also, there's been talk of doing intelligent slicing for 6G, for example, to put some intelligence into, push intelligence and computing into RANs. So all of this is very well welcome, but I would suggest that you should look a little bit more at the work that's been done in the group before saying that what we did is irrelevant.
Thank you for your question. For the role of COINRG, it's actually a research group and also like an open forum to sharing some the work on the research. Yeah, I think it's correct. But our intention to present this work in COIN is to gather some information or discussion for the maybe some the standardization work in the future, but not to change the role of COIN. So, but we have actually talked to people outside IETF and or people outside IETF. They think that COIN may be in their very initiative, their intent, their understanding that COIN may be the actually standardization group for standardizing some work in like yes. So but we want to gather some just to promote them to just raise this question to share some our understanding, not just to standardize this work in COIN, but maybe some work in other groups or in other areas in the future. So I might mislead you. Yeah.
Yeah, we are aware of the China Mobile work into the ITU and wanting to develop an ITU standardization of COIN, and that's fine. But again, this is a research group, and please bring us your research. Colin, you're next.
Actually. Okay, yeah, sure. Any questions? Yeah.
Yeah, we just changed the order. Hi, I'm Dirk Kutscher, HKUST, Guangzhou. Thanks for the presentation. I think it is, raises some interesting, brings up some interesting ideas. Quick question. So are these considerations that you presented, is this based on some, say, research or prototyping experience, or is it just an architectural thinking at the moment?
Actually, they are based on some actual research, because sorry, I didn't mention all of these co-authors. So some of the co-authors, they actually publish some the papers in major conference, so network conference, and also what I present in my slides are actually their work, the summation of their work. So I mean the framework realization, or the primitive summation. So maybe you can, I also make a reference in my drafts. Maybe you can, if you are interested, you can refer to the draft for details. Thank you.
Okay. Thanks, because I mean, there has been some, say, interesting work in distributed computing that also kind of fleshes out the interesting elements that you need to think about when you want to have this integration of computing and networking. And so some of the things you mentioned as well, so you need something like a decomposition framework
Yes.
and so on. And so I do think that these could be really interesting topics for COINRG, for further experiments and so on. So one question I had with your draft was, so the title is somehow generic framework for COIN in controlled environments. Do you think the considerations would change a lot if we didn't focus on controlled environments, but just focused on the, say, technical requirements for distributed computing in general?
Thank you. It's a very good question. I think that controlled environments is a very initial, for the deployment, it's very initial. Like current research focused in data centers, like they are controlled. So maybe it's easier to implement. So maybe to make it scalable, we think that one day that the framework may extend to an environment that not controlled or be shared by different providers or like that. Thank you.
Okay, thanks.
Thanks.
Hi, Colin Perkins. So with my IETF chair hat on, I would like to echo the comments Marie-Jose made. This is a research group. It cannot standardize.
Yes, understand. Yeah, totally understand.
And as an individual, I think there is some interesting work here. I appreciate the attempt to systematize things, develop a framework. Thinking of the infrastructure components in particular, you had some specific compute operations you were suggesting. Can you say more about how those compare to other in-network compute operations, P4 being perhaps in in-network compute languages, P4 being perhaps the most widely known, and why you chose those primitives and why you believe that set of primitives is appropriate compared to the other primitives? The goal here is, of course, to explore the research rather than to just present the ideas.
Okay. So as you mentioned, that COIN is a research group, and I understand. So what we summarize for the second question you raised about primitives, we think first, like we summarize them from most of the existing work, and also these primitives are also not the common primitives like network function related, but also I think we want to emphasize is they are actually application specific functions primitives, right? So these primitives.
Sure, but
yeah.
Many people have proposed similar application specific primitives for the network. Why do you think this set is an appropriate set rather than, for example, the sets defined in P4?
Yes, I think also I need to restate that these might be, we think that they might be standardized, or because
this is not a standards group. We are interested in your research.
Actually, actually we don't want to standardize here, but I think this might be, one day in maybe in yeah, we don't want to standardize here, but maybe these primitives can be used in common industry, or maybe implement by different network device vendors, not exactly by programmable network devices like in open source community. Yeah. So we summarize this, and these applications are mostly, they are researched a lot in the. There are a lot of research work on these applications, so we think they are very important to
Sure.
summarization these primitives. Yeah.
So going forward, I would recommend that if you're bringing work to research groups such as this, you focus on the research challenges rather than on what you are thinking of standardizing. And it would be interesting to understand why from a research point of view you think this approach is better, and how it compares with other research-based approaches in network computation.
Sure, understand. Thank you very much. Any other questions?
So, my turn. Actually, I have this is Jeffrey. So without my chair hat. So basically, I have the same question, similar as Collins. So if you want to define some primitives, it seems there's some contradiction between application-specific and some primitives at some abstraction level and widely used by many applications. So it's an ambitious, I think it's an ambitious objective to define these primitives. So how do we justify these primitives or are both necessary and sufficient for maybe future application? So I think there's some balance between in this direction. But I think this is a quite interesting research if you can justify this idea. But I think we may need more discussions or research on this. And another thing is.
So to follow up on that, I agree that it would be that this is an interesting idea, and that understanding those challenges and understanding why this is the right set of primitives would be a very interesting thing to discuss. I would like to see that discussion happening in the research group.
Yeah. And also, I like to mention is that in previous meetings, I tried similar ideas, tried to define some generic framework or generic protocol for this. So I think quite a few people envision this direction maybe in future, but at this stage, we need a more solid research to justify this idea, or maybe quite a lot of discussion or debate on this kind of definition of primitives. That's my comment. Thank you.
Thanks.
Yeah, just quickly, if I may, Dirk Kutscher again. So, right, so this work and also what Ike presented earlier, I think in principle, we agree that this is very interesting content and has lots of opportunities for the group. And I think what Colin also tried to allude to is, would be great if, so this discussion could be supported by, say, running code, real experimentation, real lessons that could be learned from really developing and using these technologies. It's really hard for the group here to assess the merits of the different drafts and proposals just by looking at slides and like ASCII informational material. So if you can move the group in this direction, I think that would be really great, and maybe also help us to provide much better results in the future.
Thanks.
Thank you.
This is
Exactly.
Marie-José
If
again.
we jump to a conclusion just by paperwork, that will be dangerous. That can be justified in later, I think, by real application.
This is Marie-José. If we want to look at all these primitives, you know, all the work that's been done by Noah Zilberman, for example, and all the people who are around the P4.org, they've looked at a ton of this stuff. And I agree with Colin. It's not that we want to limit ourselves to what they've been doing, but if we want to expand on it, I agree with Dirk that we should have real experimentation and something. And as you probably know, there's a lot of us who are working in this field who want to extend the primitives away from just the original packet header processing, but also go into a much more data-driven approach where we can also start inferring on metadata. And that becomes extremely interesting, especially when we start talking about AI and networking and digital twinning. So there is a lot of research into moving beyond the current primitives, not maybe just changing them, but adding to the richness of the field in a way, because the original applications were all, you know, data center, were very, you know, their line rate, very high data rate. But a lot of people who do research on this, and I will come back to what Dirk was mentioning in terms of distributed networks, what is happening in IoT, distributed networks, federated learning, it's all related, and it depends on primitives that are way beyond just packet level or header level, sorry. Anyway, it shows that it's an interesting discussion, and thank you for bringing it. Maybe
Thanks.
in sake of time, we want to move to the next presentation.
Yeah, okay. Let's leave the discussion on Menly. Thank you very much.
The next one is Pascal, right?
Hello?
Yes, we can hear you.
Yeah. Yes, it's better you handle my slide because I don't know how I can do that. So this is just.
And thank you, Pascal, for joining us at 3 in the morning.
Yeah, yes, it's a little. It's middle of the night in France, and so this is a very short draft. More some thought about coin security. So next slide, please. Starting from coin, for me, coin means okay, computing the networks, and it's same by deploying programs based on computed resource hosted in programmable networks devices that now refer as PND, and these infrastructures could be used typically in edge computing or that kind of stuff. And the program works with several PND exchanging data over secure communication. So the first thing is secure communication. And for me, in that context, there is a need for security first for coin as an intrinsic, that's to say, security for coins as an infrastructure, and second for programs which are running in a coin system. So next slide, please. So regarding coin intrinsic security, that's to say the security of the infrastructure itself, obviously coin should rely on a fully encrypted communication, what imply authentication and keying mechanism based on a symmetric or asymmetric secret, And so the research item for core security, in my mind, in this area are the following. First, the security architectures, that's to say, security of communication, and second, PND security model, that's to say, how much security is there in PND. Basically, it's more hardware issue. Third, a key management system. There is more in the next slide. And fourth, authentication center. So next slide, please. Next slide, please. So if we talk about secure communication used for service program deployment, you need something called the key management system, and which is a kind of secure box that will be used in order to provide key for the communication and to secure the communication. Maybe you may have some central orchestration in order to distribute keys that will be used by particular services. And let's call that for some application authentication center with also a key management system. But the idea of this key management system is to distribute key to other PND entities. PND processors can also include a physical entity with isolated or tamper-resistant computing resources. For example, you may think that part of PND processors comprise a trusted execution environment, and that means that it could be a nice place to put key inside and key management inside this protected computing stuff. Or you may think to what is called integrated secure elements, that to say that part of the PND itself has some certification and is able to have some security certification and is able to securely compute some part of the KMS. Now back to the cloud computing today. In the cloud computing, data center use something called hardware secure module, and this device typically are used to perform offload operations, let's say cryptographic offload, or KMS operation in a trusted environment. And so next slide, please. Sorry, next slide, please. Yes, thank you. So regarding the program security, the program security may have some security requirements. So through the security of the infrastructure itself, the program are download, and after some program, for example, programs that could deal with blockchain and whatever, could need to handle some security parameter in order to perform some operation, for example, interaction for blockchain. And so in this area, the security issue, in my mind, are the security program deployment. That's to say, secure program deployment by the infrastructures, attestation and secure cryptographic provisioning. Attestation means you deploy a program for a customer through COIN infrastructures, and your client may have some requirement in order to have some confidence in the fact that you need attestation, mean transferring the control by the infrastructures, or say the trust by the infrastructure to the client for use, and this implies, for example, some cryptographic provisioning. Third, the level of security and trust. That's to say a way to give some security assurance to the client. For example, in model like common criteria, in order that you may give some security insurance to your customer. And last, scalability and performance. I believe that when you deploy program in coin infrastructures, one thing is to have program in coin infrastructure with some scalability and performance, but maybe for some application, the major parameter is the level of trust and the security that you could have in this the integrity of this application. And so regarding this research, I work in the IOSC draft, which is on-demand secure computing. So it means it's kind of HSM implementing key system management procedures, and that can be reached through uniform resource identifier. So you see there this small schematic, and you see some relationship with the PND and some server that are able to handle on-demand cryptographic services. And I believe it's the last slide. So next slide, I believe is no slide. Maybe I'm down.
Thank you. We wanted to take the opportunity of your presentation to talk a little bit more about security in coin. I wouldn't call it a coin infrastructure. I would call it a coin-enabled network. And if we start thinking about this, you have your coin, your network is a bit like a computer board, and you're running an operating system on it. And your operating system are what you call a program, but I would call it, they're more like what the previous talk was talking about, maybe some primitives. But I think this is where the big security aspects happen, is that in order for that computer board to function, the nodes have to be part of the security framework. They have to be reliable nodes, or have to be like things we can rely on. So how do you see that more as instead of having the picture that you have there? It's very funny because I don't think of a coin client. I always think of more of a coin capability that is more part of, again, of that computer network, and has storage and computing elements, and all of these things are talking together. And with the evolution of programming, these things are becoming more and more white boxes, so we can do a lot of things on them. So how would you see the evolution of what you're doing into maybe a much more capability instead of, I think capability goes back to what people were saying. We need running code at one point, but I think, so my question is, how do you see that evolution of the security, knowing that if we want all these nodes to talk to one another, we have to be able to have reliable and configurable at the same time network?
The first thing is the level of security of the PND. If you think that as a traditional operating system, you have, how can you measure their integrity in a software term? For example, do you have something similar to Secure Boot, or some tools in order to check that you have no bad things running the system? And And the second thing, what is the capacity of this PND to securely handle secrets that are needed to handle all the infrastructures? That means all your PNDs are going to communicate through secure communication, and they are going to use keying system in order to work together. Maybe with some centralized architectures, with some things that will distribute key for particular configuration. For me, I read the draft for the use case and the security chapter. It mentions the need of authentication. So the first thing is authentication between PMD, and from that you have a distributed computing system where the right and the role of this PND, in fact, are fixed by cryptographic interaction and procedures. This is done in data center. In fact, in data center, you have a secure relationship between entity in order to perform a particular task.
But how does that map into like a more of a core edge, or actually a cloud edge infrastructure? Because what we see us people working on edge networks is that we cannot just use things that were done for data centers. We don't have the same, we're the networks in the small, we don't have the same capabilities. So how does that map?
From a security point of view, it's mapped if you have a distributed secure resource. Like for me, it's a box, which is a KMS, a key management system. You need to have this kind of capacity distributed in coins, because this will create the security of the infrastructure for everything, in fact, for everything. So if you have not security insurance about your PND, for example, if your PND could be cracked or attacked by some ways, this will create threats in your infrastructures.
Okay, it's interesting conversations to continue on the list. Colin?
Hi, Colin Perkins as an individual. So, I think it's interesting to start thinking about security of these systems, and there are some very difficult problems here. A lot of what has been discussed seems to assume that it is running within a single trust domain. So you can build a single infrastructure and authenticate users and programs and so on. Have you given any thoughts to the internet working aspects of the security here, and how it differs to how a sort of a compute-enabled network differs from a data center, for example, and how that affects the security?
Have we lost Pascal? Oh, no, okay.
Yeah, no. Didn't catch really the question. The question is, what should be the difference between classical data center and coin?
No, the question is,
the question
how does
is
this
that,
map into, go ahead, Colin, I thought you were off.
the question is, a traditional data center assumes a single trust domain. And I think we have a reasonable idea of how to build a security system for when there is a single trust domain. If we're building a compute-enabled network, we are potentially we potentially need to think about internetworking considerations and how to do the security for an internetwork rather than within a single domain. I was wondering if you had given any thoughts to those questions, or if the focus was entirely within single.
For me, it's not really true for me that data center are single tenant. You may have, let's say, in data center from the trust and security point of view, you have a single entity, but that's try to deliver for HSM, for example. If I'm thinking to security, I think to hardware secure modules. And in fact, there are single tenant device, but through partitions, they try to create a multi-tenant interface. And so in my research, I am more working on the idea that security is multi-tenant. That's to say that you have enough physical entity and logical entity in order to manage security and trust for multiple participants that can work after together. So my vision should be that it's the idea of to have a trust for some program in the COIN system, and so it means the security is multi-tenant. It's more a collaboration of multi-tenant, and the idea is really that you can you don't rely on a single entity like a mobile operator. Or you may have several entities, but for me, the instance of this, the facts to be multi-tenant means you have multiple source of trust in your system. That's to say you don't rely on a single trust model. And so this will be done by key management system, but managed by multiple entity and not by a single tenant like an operator.
Okay, thank you. I think that maybe the system isn't working, but Dave Oran is also in the queue.
I thought I put myself in the queue. Hi, Dave Oran, Network Systems Research and Design in MIT. I'm struggling with a different aspect of this. I'm wondering if you could shed some light on this. I take these slides and I say, what's different than if all I had was just a whole bunch of hosts on a broadcast network? It seems nothing's different. It's not really has anything to do with networking. It has to do with how you do authorization, authentication, and security and trust among computing elements, no matter where they are or how they're interconnected. So what's the actual connection to computing in the network? I'm completely missing that.
Sorry, the question is, what is the difference between multicast networks?
No, the question is from a security architecture standpoint, with the boxes you draw and who's participating with what. What's different about COIN? Seems to me there's nothing. Why do we need something different from what we already have for distributed computing, authorization, authentication, trust, and security?
It's not so easy question. It's depend of.
I wouldn't have asked it if it was easy.
It depends on security issue of COIN. And in fact, when you read all the paper dealing with COIN, there is no really people working on the security. So you have always this security to be down, or security is an important issue. The fact is,
this is what I'm struggling with, which is there are tons of people working on it. They just don't think COIN is any different from how you secure a distributed system.
The issue should be, in my mind, more in the trust you have in the different keying management systems you are using. If they are,
why do you have a different key management system for COIN than you would for any distributed system?
No, I have not different key management system. I have different key management system owners. That's not the same things.
Okay, I'll stop because I guess there's something pretty deep I'm not understanding. So I'll take it offline.
It's more about trust. If you have multiple operators in infrastructures, you have to manage trust.
Yeah,
And for example,
sorry, go ahead. I thought you'd finished.
Sorry, I'm done.
Yeah, I was just following up on Dave's comment. I think the interesting question here is how is it different, and does it need to be different from the way security is managed in existing cloud computing systems, for example?
Because the cloud computing system, let's talk, Amazon is single tenant. It means Amazon manage Amazon security and trust. And so it means if you put your data in Amazon, it means you trust Amazon. Now, if you put your data in a system which is a cooperation with different entity, you need to have to trust this different entity. It means you are multi-tenant, and it's more complex because part of your data will be managed, for example, by equipment. You don't know the level of trust of your equipment, the ability to manage the integrity, to keep the secret. You don't know that. If you have a single tenant system, it means if you are trusting Microsoft Azure, you put your data in Microsoft Azure and you say, I am okay because this is managed by Microsoft Azure and I trust this infrastructure and so on. But if you have some things with strong collaboration, with multiple equipment, then it's more difficult to have a trust in the global result of that.
Eric Nordmark, I didn't figure out how to click on the right button on the web page to put myself in the line. Maybe I can try to throw something in to clarify this. So I think that there is a difference, as you say. It's not about multi-tenant or not. It's about who has physical control of the boxes that you're running on.
Exactly.
If you care about sort of where does security bottom out, right?
But the best should be not to have a insurance about the fact that your system is working with reasonable trust.
Yes. So and that I don't. In theory, sort of the distributed compute, people might be worrying about this stuff, but it might not be explicit because they assume that somebody else, whether half my compute is running on Azure and half on AWS, I'm assuming that they took care of it and I don't have to worry about it. And there's a question about here, whether you do have to be more explicit about that. I'm having different sort of owners, operators of network equipment and how can actually manage the different levels of trust I have into those owners of the hardware that can potentially tinker with it, right? And then on top of it, sure, you're building multi-tenancy, but yes.
Yeah, but then we go into the IPFS and the blockchain world. And IPFS have tried to do things like that. It's another working group here that is, the IPFS don't come to our group, but it's there. And then you get also in DINRG, where they had a presentation on blockchain. So I think maybe that's where the thing is going.
Okay, I didn't quite understand it.
Jeffrey from City University of Hong Kong. So maybe not directly related to passcode implementation about key management system, but also but I have a problem in the security of coin. In my mind is that because in coin we usually sometimes quite a few application of coin assume that the processing in the programmable device are LAN rate, but that will maybe kind of DOS attack will be a security problem, but not directed to what we have just discussed. That's what.
I believe even knowing that your PND is your PND is something that is not easy. And likely for that, you will need attestation or certification or that kind of stuff.
Maybe not, I'm not sure. But this seems an interesting research problem because usually the network devices are shared by many other applications.
In mobile operator networks, all the equipment are managed by the mobile operator. And so it's a kind of physical trust. And all the security apply both for hardware and software. All the security apply to things that are managed by this single tenant entity. And I believe, in my opinion, COIN is more something is distributive and collaborative. So it's more difficult to reach a level of operational trust. And this also part of the security model of that. The security is secure communication and keying in order to establish the relationship with the PND, but it's also deals with the issues that you will have if you have a multi-tenant PND.
If there are no more questions, what do you intend to do? You intend to continue this work, updating your draft? What do you intend to do after this?
Yes, I believe I will update the draft with more data. From my research are more dealing with let's KMS system, but it's interesting.
I think some of the issues that were raised could be interesting to be addressed in your draft. You know, how this coin is different from, you know, standard key management systems, all the issue of discovery, which in multi-tenant and also I would say in multi-trust domains is going to be a big issue. So if I need data or if I need computing that's not in my domain, can actually even discover it. So I think there's a lot of stuff that's interesting there.
That's okay.
Okay, well, we're looking forward for the next version.
Thank you.
And go back to sleep.
Yes, good. Thank you.
Hello, I'm Zhongtong from China Mobile, and this slide is about coordination of network devices in the COIN. Can you hear me?
Yes.
Okay, I will continue. Next page, please. Okay, this graph is about network programming, and all we can think it is about the COIN, and we assume that this network devices can do some computing jobs besides just forwarding the packet. We can see that perhaps all the nodes, including the ingress 1, router 1, 1, 3, 4, and egress 4, egress 2, they are on the path for flow, and they can, if it is specified to do some work, they can do a function. Perhaps this is just an example, and I think that in the network programming, for example, in the SPAS6, we can enable this seed list in the packet header or IPv6. In the left, we can see a seed list, and the seed list indicate that in each device, each network device in the past, they can do a function. But we think it is a strict network programming mechanism because the function must take place in a specified node. Next page, please. Or in the draft, we propose this loose network programming mechanism because we think that there is a situation in Coin. We only need a function to be implemented in the network, but we do not care no matter in which node. We do not care it is implemented in which node. So we propose this draft to propose this mechanism. In this situation, we can see that we do not have a seed list. We can have a function one. We need it to be implemented in the network, but we do not specify which node must do it. So each node on the path will check there is a function one, and one of them perhaps can do the job for the packet or for the flow. It can be considered as a loose network programming mechanism in which the function may take place in any node along the path. Next page, please. This page is about we think if we need the function to be done in the path, but some coordination is needed for the devices along the path. Because we do not want a function be implemented twice or more. So a coordination mechanism is needed here. We think that we can check it on each node along the path. It can check on whether we have a job to do. For example, in this router one, it can find that we have two jobs to do, and it can choose to finish one, and then the flags change for this router 3. We have only one job left. Then at the final they reach the egress 2, we can see that all the jobs are done, and because we are not sure which device will do the job, so we think we can consider to add these functions in the off-by-hop header extension header or IPv6. So each node will check the extension header and decide whether to do the job, and check if there is a job left for it to do. Next page, please. In this page, we explain that the router will, when the router will do the job. For example, the router 3 is busy on forwarding and do not want to perform any function or tasks. It can just forwarding the packet, and some other nodes perhaps they have the ability to do the job. They will do the job according to the we call it a bitmap, because we can set a 1 in the bitmap to indicate that there is a job, and when the job is done, it can change the 1 to 0, so that at the end we can see that it's all 0, so that we can use a bitmap to indicate the function or task that need to be done in the network, so that the devices in the network will have the coordination ability to finish the job. Next page, please. This some scenario we have thought for this loose network programming mechanism. For example, network nodes can detect this DDoS attack by analyzing the characteristic of the flows and drop the packet of the suspect flows, but a node can only do it when it is not busy. So, for example, the route 1 and route 4 is not busy. You can do some DDoS attack analysis on some aspects and finish the job. The nodes can make a local decision about whether to do the job according to its status. The main job is still the forwarding. We propose the job because we think that the status in the network is very dynamic. So we want to enable the network devices to do this local decision about whether to do the job. And we want to find more use cases and have some comments from the research group. I think this is the last page. Thanks for listening and welcome for comments. Thank you.
Go ahead, Colin.
Hi, Colin Perkins, again as an individual. Obviously this idea of invoking a sort of in-network function at some point in the network with some sort of loose specification of where it happens is a reasonable thing to do. We've seen a number of other approaches to doing similar things in the past. Since this is a research group, can you comment on the research you have done to compare your approach with the other approaches?
Okay, we just now have a very initiative idea now, and we can refer to the jobs you mentioned and to make a better understanding of what we should do next. Thank you.
Okay, thank you. It would be interesting to see the research results.
This is Marie-José. As a person, Marie-José from, I changed universities, but it's fine. I'll tell people later. I also have this question of what is the research in this? Where do you feel that there is research? I don't think I really understood what this loose network programming is, but like Colin said, the idea of invoking some entity to help me deal with my network issues, there's a lot of stuff like that that's been done in SDN, for example, and it's very hierarchical and not distributed at all. There's some network function virtualization that do some things that are very similar. So it would be very interesting to hear how this is different. Is it an evolution of these things, which it wouldn't be research? So it would be interesting to see what is, like Colin said, what is the research, because I see this as, an architecture with some interesting ideas maybe, but where's, when you do research, what else, what other work, where's your state of the art, and how are you going beyond that state of the art?
Okay, I think some simple explanation. I think the SDN-based mechanism is not need it cannot can be so quickly to obtain the status of the routers. I think the router's job this meter is very dynamic. We would like they to do some local decision instead of get the instruction from SDN controller. So we propose this job, and as we think that there is few research now for this data plan use network programming. Thank you.
Okay, it would be interesting for you to add some comments on how your approach is different from what other people are doing, and because on another level, having this distributed approach is very similar to what other people are also doing in other, like Colin said, in other fields. Even if you think about it, what you're talking about could be like some kind of container based architecture where things move under, the containers are distributed. So it would be kind of interesting to hear how this is different and how this is related to current research.
Okay, thank you.
Okay, I think we should move on. I think I'm the next one presenting. Yeah, I think I'm the one presenting now. Okay. Yeah. There's somebody who has a microphone open. I hear a lot of work. A lot of sound. Sorry. Okay. So we decided to put 3 drafts inside one presentation. So I'm going to try to go through what we did. Obviously, the person who is driving the work is Ike. I think Ike and Dirk Trossen have done an incredible job. And also, I want to thank everybody else. And Xavier is on the call, so I don't know if the other authors are there, but it was really a team effort. So the use case for in-network computing has been something that we started very much at the beginning of the research group, just to have a number of good applications where we felt that in-network computing could be an enabler of these applications. Actually, it's very funny because this is how I tell my students, is that think of applications and think of what would happen if the network had computing facilities that could help your application. So this is a little bit the philosophy that we have used in what is now 3 drafts and was only 1. So I will start with this one, which is the use cases. Next slide. So that's what I was just saying. It's a short charter. So the research on use case driven requirements, and this draft is a collection of use cases coming from a pretty wide range of applications, from mobile networking, like I was mentioning before, to multimedia, and to advanced visualization. So the goal of the draft is to provide a scope for this the use case driven requirement. Next slide. So we worked a lot in the past few months on working how to make these requirements into I would say, a decent structure, and also sharing a common way of presenting them. So this use case structure is basically what's presenting there. So new current experience on things that are already existing. So mobile application, extended reality and immersive media, and interactive performing arts. A lot of these things are currently suffering a lot of times from having a strict traditional cloud, and from your thin client and from your application to the cloud, nothing happens. So we defined a number of capabilities that would be interesting to put in the network. And I will I'm sure Pascal is gone now, but it does raise issues of security. We want to put new coin systems. There's a lot of people who are looking at adding in-network control and in-network capabilities, especially for time-sensitive applications, some of them being extended reality and immersive media, but also everything related to Internet of Things and industrial control. Large volume applications, actually, there is interesting work also in ICN-RG on this, but what do you do when you have applications that are gathering an awful lot of information, be it vision in industrial systems to all kinds of IoT? You may want to have in network at that point, either in the fog or in the edge, capabilities to do the data reduction there. Industrial safety is another one, again, because you may want to do things across the network in terms of where some of the safety features should be. Improving existing coin. Obviously, the existing coin were very much into content delivery network. We mentioned all the data centers and everything, so that was there. We want to make that better. Compute fabric as a service. I mentioned Noah Zilberman before. She's the one who came up with this idea of the computing service provider, and that actually could be something that could be improved and moved into even more type of services. And again, as we move into a much more data-driven network, all of these things become very, very important. Virtual network programming, next generation NFV. I was told it's 10 years of NFV this year. And a lot of virtualization may start using in-network capabilities. And my best one, and the one that I'm currently involved with, is all the distributed AI and what happens when you start having federation of AI capabilities, and that you need not only distributed networks, but the way to deal with these incredible amount of data again. So we worked a lot on that. Next slide. So the current status is, I think we're finished. We have, and we invite the group to really look at it. All our use case description are aligned with the taxonomy, which is the next presentation. Because we had, in order to describe the use cases, we had to agree on a taxonomy, so we did that. We think that, again, from our point of view, and again, talking for the whole team, we've considered that this is finished. That I think we made a good point for each of the requirements and the use cases, and we would like this to go into research group last call and have move forward with this towards the next steps. Obviously, I will let the other chairs talk about this because I'm not presenting this as the chair, but I'm sure that we can, we would like this to be posted to the list and request a research group last call. Next slide. So now that's the other one. Like I said, at first, for those of you who followed our saga, we had everything in one draft, and we realized that the defining of a taxonomy and a terminology and a way of semantically describing all these requirements, that is, we had to define so much terminology that it was obvious that we needed another document. So we split the terminology outside of the use cases. Next slide. So again, we well, and actually, I'm going to have a double hat. On the second point here, I'm going to have a double hat. But we needed, like I said, the terminology, and we are still encouraging me as my as an author in this research group, but also as a co-chair that since the draft Kushner has expired, although that one was a research group document, we decided to do our terminology a little bit independently, but we would love, and I think all the chairs would too, to have this the draft Kushner being rekindled, and maybe we can discuss that after I'm done. So again, we moved the terminology to the dedicated document. One question that we have to the RG is, should we continue managing this document, or should it be taken over by someone else? Ike is working on his PhD, and obviously there's a lot of authors, but we're figuring out, are we the right group to continue this? Should we collaborate much more with Dirk and Jorg on the other COINRG directions? And so this is a question that we have for the group. We don't know, or we are not sure. The goal of the document, I think personally, I think it should be a living collection of terminology, but are we going to ever have a final version of this? That's another good question. Again, and it goes to the last point, which is, what are the changes? What are the additions? We have a number of new documents, of new approaches. We probably need a whole section on security type terminology and other related topics. So again, it goes back to who's going to take over the management, and what should be the scope of this, because of course terminology can grow like crazy. And I can tell you that in our previous research group in network coding, it took us a number of years to figure out what the real terminology would be. So it's pretty big work. And again, those are questions that we would like the group to help us answer. And obviously, we're going to put some of these to the list. Next slide. So I won't go to all of this, but we decided to have fairly definitive terminology for, let's say, a programmable network device. And we said such because we know that there's going to be others, but things that are inside the network and are programmable using P4 or other languages. And we would like these to include network interface cards and switches, but maybe at one point other type of hardware as it becomes available. And there's a lot of work on that also. And we use P4 or other languages, again, because we are fairly much aware of the limitations of P4, and that at one point, maybe we would need to have better languages to do it. We defined an execution environment where essentially where we could execute a function. We defined a COIN system as not only the PNDs and their execution environment, but also all the other communication resources and I would say the storage resources. And we wanted to go beyond the single provider and have multiple providers, which goes back again to one of the previous presentations, to offer COIN capabilities. We wanted to make sure that a COIN capability was not just a processing and computation, but also communication. so that we are not just edge computers, we are communication devices, so we are computing and communicating. We wanted to have a COIN program. We have this idea of the COIN program, and I think there's probably going to be an evolution of that as we think more of some of the applications. But I would say for the moment, we're talking of a number of I would say a non-monolithic approach where we actually want to orchestrate a number of COIN programs, or actually of execution of some pieces of software. And the idea there is that, we want to orchestrate and federate all these devices. A program instance, well, that was actually something very simple. It's one instance, and it is most likely communicating with another instance, because again, we're talking about this in terms of a network. And we define the COIN experience. I think that's fine, and I think it's important for defining what an application gets from COIN. And so we defined it as something new and probably better that is brought when we have COIN capabilities. I call it, again, to my students, I call it COIN capabilities on the life of a packet. So from where a packet is being generated to all the way to where it's going. So is the COIN experience making the life of a packet and the life of the application that needs all these packets better. Next slide. Well, that's just an overview. So after we did the use case and the terminology, well, the next one is, are we going to stop at describing things, or are we going to do more research? Because right now this stuff is what we have is essentially opening up some good questions, and that's what the use case document does very well, is opening up directions for research. So we started thinking, should we do another? Well, let's put it this way. When we did the work at the beginning, we had in the use case not only the requirements, but also elements of analysis, and it was uneven. Some of the use cases had already more in-depth analysis existing, some less, and so the document was a bit messy. So we decided to take the analysis again out of the use case document and making itself into another document, and that one is fairly new. Next slide. So this is to go beyond the descriptions and to allow to analyze opportunities, to analyze research questions and requirements that actually, and those requirements that are common and actually could give in-depth research direction for COIN based on, again, this ensemble of different use cases. So it started with, and actually that's the status. What we found that there are good research questions, but we would like to go into deeper analysis, and the little ASCII thing here, who described this ASCII? Well, it's the ASCII thing again. So that there are application area of applicability. We have, again, identified things related to transport, application design, data processing, that includes network elements, routing and forwarding, which could be helped by adding in network computing, I would say more and more, also probably load balancing, which was at the beginning, and congestion control is probably there. Industrial control is something that I'm very much aware is a real big applicability area because it touches so many elements in data-driven approaches. We see also distributed computing frameworks and languages for COIN. P4, like I said, is pretty limited, so there could be very interesting distributed computing. And I would say a combination of distributed computing and networking frameworks. What are the enabling technologies? There's new hardware. NVIDIA and Intel are involved in new hardware for some form of intelligent computing inside the network. And that's actually part of the enabling. That's not research, but there is research in enabling technologies. And what would be the visions for COIN? And I think the visions for COIN, we probably, each one of us has one, but it would be interesting to investigate which of these visions could lead to more in-depth research. Next draft. Next draft. Next page. So again, questions for the RG. We started this, again, the same type of people, the same group of people, so it's always us. So who can take over managing the document, especially with Ike, who may graduate soon. But I think it's an important document, and we feel that it would be important to do these analysis. I think this whole presentation today showed that there's a lot of people asking some interesting questions about what are the validity of the research that's been done, and is it going in the right direction? Obviously, people who are doing the work, we have our own view of where this could be going. And it would be, I think it's important to do the analysis, because right now it's interesting to say, oh, great, in-network computing is perfect for federated learning because we need it. But it's another thing of saying it's perfect for federated learning because we did it, and it is much better than what is happening, or by distributing the computing from the data center into the edge network, or going back to the edge network, which, like some people have said, it's more eco-friendly and it takes away a lot of the big ecological impacts of data centers. But again, that analysis needs to be done, and we feel that this is something important for the group. I'm done. I think it's the last slide. And again, I'm sorry that Ike wasn't there to present it, because I think he did a lot of the work on this. And okay. Is that for me? Anyway, I'll look at the questions. Are there any questions? And again, we since Dirk and Ike are not there, I would recommend that people read the drafts, and that questions could go on the list so that everybody can participate. And but again, I think the take home on these three drafts is, one, we would like the use case to go to research group last call. The terminology is something that needs to evolve, and the analysis is something that needs to be done.
Yeah. Any questions or comments or suggestions from the audience?
And since Eve has joined us after having all kinds of problems, maybe Eve, you want to take over the last few minutes of the meeting to discuss future capabilities. Oh, Dirk is there. Okay.
Yeah. Hi, quick. Dirk Kutscher, HKUST, Guangzhou. So on all of these documents, also the COIN directions that you mentioned earlier, and we didn't update for some time. I think one general question for the group is how many documents and of which nature do we want to push towards the REC editor direction? And so, of course, in general, it's good to have, say, high quality output and then document this as RFCs as well. But for example, for the coin directions draft that we started, we actually were not quite sure. I mean, so these drafts can serve different purposes, right? So one purpose is to just have something to talk about in the group. And another purpose could be, to publish something maybe to the outside world, and something that also maybe has a bit longer relevance. And so sometimes I'm not quite sure, say how many documents we should actually, publish as RFCs. So personally, my preference is to focus on experimental specifications mostly, and then if there's any other important and say mature enough, say architecture work or some analysis work, of course that could be considered as well. But I could see it could be problematic, right? If there is like too much informational material that we try to get published.
This is Marie-José. I agree, but would you want I think your draft was very important for this group. So, I think personally, I think also in the name of Jeff and Eve, who were expecting this to go further. I agree that we shouldn't spread ourselves too thin. But for example, about a month ago, who was looking for information about coin, and I would have loved to be able to direct them to your draft. So my answer is maybe we don't need to make that decision now. Maybe at one point we will bring back the terminology in the use cases, and maybe the use case analysis will go back in the use case. But I think I don't know if we're there. Because I think part of the discussion is that we have a number of interesting things that were started, and Eve, your discovery draft is also expired. But I don't know. I will return the question to you. Does it matter?
Yeah, thanks.
For now?
Thanks a lot. I mean, we don't have to make a decision right now, and I also want to apologize for not having done these updates. Just life came in the way with too many other things as well.
You're all there.
But happy to discuss this maybe offline, and maybe let's try to find a good set of documents that we would like to continue developing.
Okay, thank you. There's Colin is in.
Hi, Colin Perkins. So I agree that it is a good thing to think about the set of documents this group should produce, and to be strategic about what those documents are. I will remind you again that as a research group, the focus isn't necessarily on drafts, it's on understanding. And there are many ways of getting that understanding, and drafts are one of them, and are perhaps a very useful way of organizing thoughts. And sometimes it's certainly appropriate for research groups to produce RFCs and experimental specifications and so on. But research papers and collections of papers and organizing material is also useful. And we as a research group don't just focus on drafts, focus on the research and on organizing that research and being able to point people at the research the group is doing rather than the drafts the people are doing.
Yeah, and I think that the use case draft, we wanted to go around with a little bit of the state of the art in research. So, it's a meta document for the research that's existing. But I know it. But at the other, we've just had that discussion before on documents. But at the same time, it would be nice to capture somewhere the flavor of coin that we want to push as a research group. but I follow you, so
Yeah,
we don't have to do this.
I agree. It's very useful to have this material and to be able to point people at it. I will just encourage you to be creative about how you do that, and drafts are not the only mechanism for doing it.
Yeah.
And sometimes they're very appropriate, and pushing things to RFCs is very appropriate. And sometimes for a research group, there are other ways which achieve the goals better.
Sure. We have 1 minute left. Eve, you want to add something?
Sure. Can you hear me?
Sure. Yes.
Thank you for your patience. I had an email change, and there was some sort of authorization problem that prohibited me from logging into MeetEcho, which we solved in the background. That said, in terms of going forward for this group, one of the things that we have talked about with regularity but haven't delivered on is to have perhaps an interim meeting where we do a little bit of this retrospective. Where are we now compared to when we first began? And I think it actually, in light of this past discussion or dialogue between Colin and Marie-José about how, and even Dirk, is, how to use the working group in terms of creating specs versus creating an organization of collections of research. One thing we would really like to do is to have maybe this interim session and talk about how the field has evolved since the time we started this group. So I think that is top of mind that we'd like to get to. We would like to set an interim between now and July to do that. And perhaps alongside of that, we try to gauge what are the best ways to be creative about achieving that state of the art and pointers for those who come into the COIN arena looking for how to navigate it and how to get started and how to level set. So I think that's all I'll say here for now. And thank you for running such a great meeting, Marie-José and Jeffrey, without much help from me, although I did try to capture minutes from the moment I jumped in. So thank you all.
Thank you so much to Kiran for having
Yeah.
been inside the room and replacing us. And thank you very much to everybody. And we're over time. So I think your point, your conclusion, Eve, was perfect. So it's great. So have a good rest of day for the people in Japan. And it's 10:30 p.m. here, so I guess it's start of the evening or end of the evening. And for people in California, we'll have a great evening.
Thank you.
Bye.
Bye-bye.
Thank you, everyone. Bye.